Hey guys, what do you mean by energy? How the energy can be correlated with the work done? So those things we are going to discuss today, guys. So previous class we have discussed more on power and plenty of good concepts in case of conservation of energy and power consumption calculation we have done. So today we are going to dealt with what do you mean by energy. So energy is nothing but work done, the work done by an external agent on a body. On a body gets stored as energy. Energy in the body. So this is what the exact physical definition, guys. So the work done by the external agent on a body which will be stored as energy. So if you are moving a block from a lower, let me say lower the mountain, and we are bringing making a work done and making that above the mountain, then we are lifting that from the mountain, the energy, the kinetic energy will be getting forward from there. So that is what the energy stored in the things. So if you guys, the water will be stored at the top, and once that is released from the top, it will be going down. So that is how the thing will work here. So here the change in energy. So the change in energy, which is equal to work done, or we can also relate that as a q del v. Okay, so this we already saw, right? So similar to that only. So energy, the del u can be written in like this way. Okay, so this is the change in energy that we can take part with the help of thing. So even in the power we have took this, right? So here the work done we are done, right? So work done formula we are change making sure that with the energy. Okay, so work done by battery in the circuit is nothing but the energy delivered by the battery. So that is what the thing. So work done in a battery, so let me write this definition. So work done by battery in a circuit, which will be equal to energy delivered by the battery. Okay, so let's get into the previous year, guys. So these are some fundamental questions. I'm not sure this is from previous year or not. My team gave these questions to discuss here, so I think this will give some good idea over understanding the fundamental things. So let us see. A current of 0.5 amps is drawn by the filament in an electrical bulb for 10 minutes. Then find the amount of electrical charge that flown through the circuit. Okay, guys, so please pause the video and try to relate and find the answer. So let me solve the answer. If you guys are able to solve it, please post in the comment section that you are able to solve it and with the answer, so that I will be very happy to see that. So here they are asking the electrical charge. So we know the simple relation between electrical charge, that is I over dt, because here they asked for 10 minutes the change in time. So I is constant here, so time applied is also constant here. So let us be apply directly. So zero point 0.5 into time is 10 minutes, so we have to convert that into seconds. So if we apply, then this will be 300 coulombs. So thing is that the amount of electrical charge that is observed or flown over the filament in the electrical bulb for the 5 minutes with the zero point 0.5 ampere, which is nothing but a 300 coulomb. So that is what the question, guys, so they asked. So second question is that they are given an electrical circuit. So this question also, please pause the video and try to answer it. So this is one question. So question is that in an electrical circuit, an energy of 0.25 microjoule is required to transport zero point 0.5 microcoulomb from point A to B. So what is the potential difference exists between these 2 points? So this is one good question, guys. So there is some relationship between energy and the work done that we already know. So we know that the energy which is equal to work done. So just now we saw, right? So the definition. So we know that the energy, the change in energy, which can be related to work done. We know that work done which is equal to q d, the potential difference, or del v. Okay, so this we know. So here they gave the energy. Energy is nothing but 0.25 coulomb. So microjoule. Okay. So the q, which is nothing but zero point 0.5 micro coulombs. So that they are given. So now they are asking what will be the potential difference that is existing between the 2 points. So if we divide these two, the coulomb will cancel. So 9.25 92.5 if we take the thing outside. So this answer will be 18.5. Okay, 18.25 volts. Okay, so this is how we can solve this question. I hope you guys able to get it right. So these are some very good easy questions only. So here comes a good question. So you guys try to solve this question. So pause the video and try to answer it. If you guys able to achieve it, I'm really very proud of you guys. So that is this is something that is advanced question. I took that. Yes, not advanced. So far we discussed. So this is quite good question. A certain circuit element has the current and voltage. So they given both the current and the voltage. They are asking us to find out the energy. So we may not know the direct relationship with the energy over the I and V, but we know the power which is equal to VA. So which is related here. But here if we see the thing, this is depend on T. So means we have to calculate the instantaneous power, that is P of T. So P of T is nothing but V of I into I of T. Sorry, V of T into I of T. So once we able to get the power, then what we can do is that we can simply find out the energy. So energy is nothing but the integration of power over the time period. So that is what the thing. So because we know that the energy is nothing but the area under the power graph. So that is a simple relation that we already know. We know the thing, right? So E which is equal to, so P which can be calculated from E by T. So that is what the relationship I took here. Okay. So from here we are making sure that. So first let us calculate the instantaneous power. So P of T which is equal to V of T into I of T. So if we the constants get multiplied, so this will be equal to 500, and if we write the rest of the term, that will be e power 500t into 1 minus, right? So if we bring that together, then minus e power. So e power a, e power b, that we can add both the two together. So if that gets added together, then it will be 10,000. So this will be 10,000 t. So this simple thing. Okay. So this is how the value of instantaneous power that we are getting. Further we cannot reduce this. So if we need energy, then we have to integrate thing. So constant will be outside. So if we integrate this from 0 to infinity, because they are asking t is greater than 0. So if we are integrating this, so e power 5000 t minus e power 10,000 t, okay, dt. So we know that the integration formula e power ax e power a dx, which is equal to, sorry, e power ax over dx, which will be equal to e power ax divided by a. So that I'm going to apply here. So it means 500. So e power minus 5000 t divided by minus 5000 minus minus plus way I'm making that. So 10,000 t divided by minus 10,000 will come. I'm changing that into positive. So 10,000, right? So I'm adding on 0 here. So the limit is from 0 to infinity. Okay. So we know that e power 0, which is 0, e power minus infinity, sorry, e power 0 is 1, e power minus infinity is 0. So once we take this and we solve this one, so we will be able to get the answer that will be equal to 0.05. So 0.05 joules. So that is what the energy that we'll be getting, guys. Okay. So we know that e power minus infinity is 0, e power infinity is 0. Okay. So e power 0 is 1. So from here, so when we substitute the upper limit minus infinity, that will be 0. And if we substitute e power 0, then this will be 1. So 1 divided by 10,000 minus 1 divided by 1000. So from there, if we cross multiply and take the things, the answer will become as 0.05 joule. So from here, we have completed our fundamental discussion on everything. So from next class, we'll be going to the next topic, that is classification of network elements. So I will be starting with what you mean by node, what you mean by branch, and those things I will be starting from next class. So I hope you guys had a good foundation here. So if you guys able to understand, correlate what are the things I'm saying, then our network theory will be very much easy. So you guys will enjoy my lecture. So I am assured that you guys will take a good marks in network theory if you guys continuously watch my entire network theory and even other subjects also. So please like, share and subscribe the channel. Please motivate me to post more good contents like this. So I'm suggesting you guys also to share these contents to your friends so that they also be getting learned over that, so that I can also gain some subscribers and my views, right? So that's why I'm suggesting you guys to like, share and subscribe the channel. Thank you guys. Stay tuned.